Okay, so this is the third video on the introduction to hyperbolic functions. On the left hand side here you can see we have cosh of t is equal to e to the power of t plus e to the power minus t over 2, and sine of t is equal to e to the power of t minus e to the power minus t over 2. On the right hand side here we have our unit hyperbola, x squared minus y squared is equal to 1. And we have our unit out here, our 1 out as far as here. And our x values are going to be cosh of some value t, y values are going to be sine of some value t, where t is going to be twice this area here, this shaded region here. So in this video I'm going to have a look at showing that this area here is in fact t over 2. Okay, so here we have, this is going to be t is equal to 0. This is times 0 here. Okay, now let's just work through that. So what I'm going to do is find this area here using integration. So what we're going to do first is find the area of this triangle here, and then we're going to find the area underneath the curve here, this blank area here, subtract them, and that should give us the area of this shaded region here. So let's do that. So the area then that we're looking for is going to be equal to half the base times the height. The base is cosh of t, and cosh of t is e to the power of t plus e to the power minus t over 2. Our y then is going to be sine of t, and that's e to the power of t minus e to the power minus t over 2. We want to subtract the integral from 1 out as far as some x value of our function y with respect to x. So let's continue on with that. First thing we're going to do here is multiply out our denominators, so that's just going to be 1 over 8. Let's multiply out our numerators then. We've got 1 times these two things here, so let's multiply those two out. So we've got e to the power of t times e to the power of t, that's e to the power of 2t. We've got e to the power of t times e to the power of minus t, that's e to the power of 0, which is 1, so that's minus 1. We've got these two here, e to the power of minus t, e to the power of t, that's going to be plus 1. And then finally we've got these two here, which is going to give us minus e to the power of minus 2t. That's our left-hand side of our expression done. Let's have a look at our integral now here. You can see here that these expressions here are in terms of t, whereas this expression here is in terms of x. So I'm going to change these to t. So it's going to be, our integral needs to go from 0 to some value t. Our y here is just going to be our sine of t, so that's e to the power of t minus e to the power of minus t over 2. We want to get rid of this dx here, or change that in terms of dt. So let's see if we can do that. I'll just do that separately down here. So we know that x is equal to cosh of t, and cosh of t is e to the power of t plus e to the power minus t times a half. So if we differentiate dx dt, we'll get half e to the power of t and then minus a half e to the power minus t. The reason for the minus here is that if we differentiate this, we need to differentiate the power as well, and we'll get minus 1. Bring it down in front, so that changes that to a minus. Multiply across by dt, we get dx is equal to a half e to the power of t minus e to the power minus t dt. So that's what I'm going to put in here then. So that's our dx, which we've got to change to dt if you like. So let's do that. So we've got e to the power of t minus e to the power minus t over 2 dt. So now everything in here is in terms of t. So let's continue that on down here. Now this here is in terms of t, and we've got to substitute in a t. We could leave it as it is, but maybe we'll just change that power here to a different variable. Doesn't really matter, but just for neatness sake, maybe I'll just do that. So we've got our 1/8 here, and we've got e to the power of 2t, minus 1 plus 1 is 0, minus e to the power of minus 2t, minus the integral from 0 to t of, I'm going to take out, actually what I'll do is I'll take those halves out, so it'll be a quarter, I'll take that outside the integral here. And then we've got 0 to t, e to the power, let's say u, minus e to the power minus u times e to the power of u minus e to the power of minus u, and that's with respect to t. Now let's just finish this off. We've got 1/8 e to the power of 2t minus 1/8 e to the power of minus 2t. We've got minus 1/4, and what I want to do is just multiply all this out. So we've got from 0 to t, e to the power of u times e to the power of u is e to the power of 2u. Here we've got, well, let's do this one first. Here we've got e to the power of u times e to the power of minus u, that's going to be minus 1. And then here we've got another minus 1. And then here we've got a plus e to the power of minus 2u dt. Okay, so what do we end up with here? We've got 1/8 e to the power of 2t minus 1/8 e to the power of minus 2t minus 1/4. So we've got to integrate all of this here. So e to the power of 2u is going to be 1/2 e to the power of 2u. Minus 1 is minus 2. If we integrate that, we get minus 2u. And then if we integrate e to the power of minus 2u, that will give us minus 1/2 e to the power of minus 2u. And we want to integrate from 0 to t. Okay, so let's just substitute in our limits here. We have, let's see, 1/8 e to the power of 2t minus 1/8 e to the power of minus 2t minus 1/4. Let's see, we have to put in t first. And you can see why I changed the t's here to u, because we're substituting in t for u now rather than t for t, if you like. But anyway, let's see, we've got 1/2 e to the power of 2t minus 2t minus 1/2 e to the power of minus 2t minus, now we've got to put zeros in here, so it's 1/2 e to the power of 2 times 0 minus 2 times 0 minus 1/2 e to the power of minus 2 times 0. Okay, so now we've got a 1/8 e to the power of 2t minus 1/8 e to the power of minus 2t. Just going to multiply all this out now by the quarter. So here I'm going to get minus 1/8 e to the power of 2t. Here I'm going to end up with plus 2/4, which is 1/2 t. Here I'm going to end up with plus 1/8 e to the power of minus 2t. Now this is actually a minus here, so that will be minus minus plus 1/8 e to the power of 0, which is 1. This here is just going to be 0, so we don't have to worry about that. This here will actually be plus, minus minus is plus, and then multiplied by this minus, which will give us a minus. Again, it's 1/8, and it is e to the power of 0, which is 1. Okay, let's see. Hopefully a lot of these things will start cancelling. Let's see what does cancel at this stage. We have 1/8 e to the power of 2t minus 1/8 e to the power of 2t, so that's gone. We have minus 1/8 e to the power of minus 2t plus 1/8 e to the power of minus t here, minus 2t here. We have, let's see, we have plus 1/8 e to the power of 0 minus 1/8 e to the power of 0. So they will disappear, and look what we're left with. We are left with what we set out to prove. We end up with a 1/2 t, or just t/2. So this is the area, this is our shaded region. So that is it.